Hi, Randon. Sorry to take so long to get back to you. I've got a picture for just a general loon. This is the one from part one. And it doesn't really matter which equations we use for the circle for part two for the general situation, as long as they don't both have their centers at the same point. So how I set this up was I let the little circle be x squared plus y squared equals little r squared, and I had that centered on the origin. And then for the larger circle, I had x squared plus y minus k squared, just k is any constant that would move the circle up or down. And then I let the larger of the radii be the capital R square. And so from there, what we did was the same sort of procedure that we did for the first example where we had the actual numbers, because all we're trying to do is come up with a generalized formula for when we form a loon between two circles of unequal radii and different centers. And so in general terms, what that looked like was an indefinite integral because we don't know the points of intersection between the two circles unless we have more information. And we would be taking, in this case, the larger of the two circles is the top curve, so that's this one, minus the smaller, which was the red one. And so if we rearrange our equation the same way that we did in part one, then we would end up with k minus the square root of r squared minus x squared for our first function. And then we would be subtracting the square root of little r squared minus x squared dx to finish it off. And in general terms, you would end up with a general integral for all of that, which is quite messy with a bunch of arc signs and stuff because you can't sort of work out the arc signs until you have a number for the radius. But you will get an equation, you will get a formula with a plus c in there, and if you had more information, such as the points of intersection, then obviously you'd be able to use that formula to find the area of the loon between any two circles that intersect in this way. So that's the way we approached it, and it sounds like that's what Stefan is looking for. He said that number two should be able to be done exactly like number one, and so I think that what we were looking at is just a little bit too higher level in terms of what this problem is asking you to do, especially for the 3 marks. So if you follow that through and find your integral, you can check it on Maple, or I use one called Symbolab. I don't know if I mentioned that to you before. And you can just feed the integral into that website, and it will give you all the steps and the final result. And you can check your answer against that and see how you did and make sure that it's right. Okay? So please email me back. I promise I'll check it again today. It's just been a busy weekend because I'm on exams right now and my son is sick. So let me know if you need more help with this, okay? Thank you.